In this problem, we are told that 1 over a plus 1 over b is equal to 1 over 13, where a and b are in the natural numbers, and we need to find solutions for a and b. So starting off with our equation, first thing I would notice here is that we've got fractions. So let's try and get rid of these. So firstly, I'm going to multiply through by a. So our first term becomes 1. We have plus a over b equals a over 13. And I'm going to do the same thing with the b. Multiplying through by b, we get b plus a equals ab over 13. And then multiplying through by 13 gives us 13b plus 13a equals ab. Note we could have just taken the first equation and multiplied through by 13ab all in one go. I've just broken it down so we can see each of the steps. Now I'm going to move everything over to the same side by subtracting the 13a and the 13b. So we get ab minus 13a minus 13b equals 0. Now looking at our three terms here, we can see that they just share three different items. We've got a that appears in two of them, we've got b that appears in two of them, and we've got 13 that appears in two of them. So this gives us a hint that we can be doing some factorising here. So firstly, I'm just going to factorise those two first terms. I'm going to take the a out to give us a lots of b minus 13. That's minus 13b equals 0. The next step is a little bit trickier to see. But if we can create this so that we've got two brackets multiplying together, as we're dealing with natural numbers, whole numbers, that's going to put us in a good place to solve this. And as I mentioned before, we've got that 13, we've got that b repeating themselves in different places. So what I'm going to do is I'm going to factorise out the 13 from the 13b, but I'm going to create another bracket of b minus 13 so that we can then do some simplifying, factorise things. So what we've put here is I put that second bracket of b minus 13 in. If we multiply this by minus 13, that gives us the minus 13b that was already there. But then to keep this bracket the same as the first bracket that we created, I put another minus 13 inside it. However, this would change the value of our left-hand side. We'd have minus 13 times minus 13 equals 169. So I've taken away 169 on the end there to keep it the same. Now, if you're unsure, if you just multiply out the line that we've just written, you can see that we'll get back to what we just had. I've just rearranged it in a different way. So I've got b minus 13 in two different places. And now that we've done this, we can factorise out again. Because we've got a times our bracket, we've got minus 13 times our bracket, we can rewrite that as a minus 13 times by our bracket of b minus 13, and we've still got that minus 169 on the end equal to 0. Now if we move that 169 over to the other side, we end up with a minus 13 times b minus 13 equals 169, and as we know that a and b are natural numbers, this means we've got two brackets which themselves are natural numbers multiplying together to give 169. So we can now solve this. 169 is an excellent number to work with because there are so few things that will multiply to make it. We've got three cases. It's either going to be 1 times 169, 169 times 1, or 13 times 13. As 13 is its only prime factor, these are the only things that we can split it up into. So let's look at these case by case. So for case 1, 1 times 169, that would mean that a minus 13 must equal 1, and b minus 13 must equal 169, giving us an answer of a equals 14 and b equals 182. Case 2, 169 times 1, well, by the symmetry of the problem, both our brackets are letter minus 13. We've just switched them round. So a would equal 182 in this case, and b would equal 14. And for our final case, where 169 is 13 times 13, we get a minus 13 is 13, b minus 13 equals 13. So both a and b are 26. So there we have it. We've got three pairs of solutions. We've got 14 and 182. We've got 182 and 14. And we've got the trivial solution, which we maybe could have seen from the beginning, of 26 and 26. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.